Hey, this is Dr. B, and if you've been watching some of my slides in order, you realize that we've shown about a dozen different slides about the electron. Why don't we summarize things with a little fact sheet? Here's our early model of the atom and where the electrons are that applies fairly well to the hydrogen atom. Well, at least that's one element that we've got covered. And electrons seem to reside in shells. We now know that there's subshells within that, and there would be the 1s subshell, 2s, 2p sub x, 2p sub y, 2p sub z. So if you're really trying to visualize the atom and where the electrons are, these sorts of progressive images should help. So the electron does exist. This was determined by Thomson. It was located outside the nucleus. That was determined by Rutherford. They exist largely in shells, at least to a first approximation, and definitely for hydrogen. That is the work of Bohr. They can also exist in subshells. This is the work of Heisenberg and Schrödinger and others. They exist within orbitals. Those are paired groups of electrons, and Wolfgang Pauli determined that when they are paired, they go with opposite spins. There is experimental evidence for all of these suppositions. It's believed to be an elementary particle, which means you cannot take a knife and cut it in half. There is nothing within it. It's just an electron. Well, I guess there's something within it. We should also point out that it's not quite a thing. It's so small that its properties resemble somewhere between light and matter. It can be weighed, I guess, and I wonder how that works out since it's not even quite a thing, but it has a mass of roughly 10 to the minus 28 grams, or another way of looking at it is that it's almost 2,000 times larger than a proton. When people come up with average atomic masses, they ignore the electron largely and just work on protons and neutrons. And if you want to visualize what the electrons are doing around an atom, I've got an entire region. We're going to go from 1s2 out, say, 10 shells or so, well beyond the universe. So just enjoy this little visualization. I see some p orbitals. I see some d orbitals. I see some f orbitals kicking in eventually. And perhaps as we go further out, you'll even see G and maybe H orbitals. This is what an atom would look like if it could hold all those electrons. Don't forget that largely these things are believed to be so unstable that they are really more of an anomaly rather than anything else. Anyhow, that is a fact sheet for the electron.